Hello everyone, welcome to these pre-webinars. Good morning, good evening, good afternoon, and good evenings. Welcome to Institution of Global Professionals in these pre-webinars. I'm hoping that you guys are doing great, and we are going to interact an amazing sessions. My name is Nur Azim. I'm from Bangladesh. I've been working for an automobile company in Bangladesh. Ladies and gentlemen, IGP is one of the largest community in the social media. I'm proud to be associated with IGP as a global member and host, and also I'm really happy and delighted to conduct today's session. Today's session with Nilesh Pandey, Dr. Nilesh Pandey, sir. I'm hoping that we are going to learn something really new. Once again, thanks to everyone for joining with us, and thanks in advance who will join with us with these sessions. In this session, we will learn about the green chemistry and MAOS. Once again, I'm requesting everyone, don't forget to share and with your friends and family members, because sharing and caring, and we can really help each other by sharing. If you really have any question about the topic, about the speaker, about the, if you are facing to understand any questions or any topic, you can comment below. After the session, our honorable guest, he will try to answer the question all of yours. And best the most interactive audience will be certificated, will be provide certificate from IGP. That is really remarkable. Every day we get some new members from all over the world. So for them, I would like to uh, give a short brief about the IGP. So what is IGP and what is doing here? IGP is Institution of Global Professional, is an educational institute which provide social work. We believe that not only formal education can enhance our life, because time and technology already growing up so fast. So we are providing effective and time-wise some skills and training. Especially, we are focusing on the education, communication skill, soft skill, and also some time demanding topic from the from the like well trained and courses we are inviting from the globals. IGP already reached 100 countries over the globe. This is really amazing. Every day we are conducting more than 3 webinars where you can learn so many things. So once again, I would like to invite everyone. If you really want to share, if you want, you can share with your friends, because sharing is caring. It can really help you. So, ladies and gentlemen, we are going to start the session. Now, I would like to invite our honorable guest. Don't forget to comment here. Our honorable guest, Dr. Nilesh Pandey, sir. By the way, we are conducting today's. Already, we have finished 406 webinars in the meantime, and today is the 407th session. And I'm hoping that we can learn something together and we can enhance our skill as well. Welcome to, we are inviting our honorable guest. Thank you so much.
Okay, thank you, sir.
Hello, sir. Good evening.
Good evening, good evening. So I would like to welcome all the participants, and I'm very proud to associate with the IGP today. So give me the platform to present my presentations, and today I'm going to deliver presentations on the green chemistry and the microwave assisted organic synthesis. First of all, I would like to introduce myself. Myself, Dr. Nilesh Pandya. Uh, I'm MSc PhD. Right now, I'm working as an assistant professor in the Ukhat University, Bardoli, Gujarat. And right now, I'm working. My research area is the green chemistry, as well as I'm also working on the nanoparticles. So today we are going to discuss about the green chemistry and the microwave assisted organic chemistry, organic synthesis. So first of all, I would like to say what is the green chemistry. First of all, we have to understand what is the green chemistry. So that green chemistry is a design for the chemical product or process that reduce the eliminate the generation of the hazardous substances. Like EPA efforts to speed up adoptions of the regulatory of the device and discipline have led to significant environmental benefits involved in the stated economy. So first of all, we have to understand what is the green chemistry, that the definitions of the green chemistry, that the, how can you define the green chemistry? All of we are very familiar with the chemistry word, but what is the green chemistry? That the green chemistry is basically design of the chemical product and processes that reduces or eliminate the use or generation of the hazardous substances. That the green chemistry applies across the life cycle of the chemical products, including design, manufacturing, uses, or ultimate disposals also. That the green chemistry also is a sustainable chemistry, mind well. So now what are the green chemistry includes? First of all, we have to understand what is the green chemistry itself includes. So these are the basic 12 green chemistry principles. But what the thing that we have to learn before the studying the 12 principle of the green chemistry, what green chemistry prevents? That prevents the pollutions of the molecular level. So this is very, very important. The green chemistry itself prevents the pollutions at the molecular levels. It is the philosophy that applied all the areas of the chemistry, not a single discipline of the chemistry. Mind well, this is the most important thing, that it's include all the area of the chemistry, not only the physical organic chemistry or inorganic chemistry or like physical chemistries and all that, but it includes the all the area applied innovative scientific solution to the real world environmental problems. Nowadays, you are very familiar with that we are facing a very greenhouse effects and all the other gases and pollutions levels and all that. So basically, green chemistry targets on the specific real world environmental problems. This is very important. Result in the source reduction because it prevents the generations of the pollutions, reduces the negative impact of the chemical product and processes on the human health and the environment also. Lessons sometimes eliminate the hazardous component or exist product from the processes. That we can use the alternative method or alternative substance like ionic liquids are there, some green solvents are there. By the use of this particular component, by the use of that particular solvents, we can eliminate the hazardous components which are regularly used in the conventional processes. So design the chemical product in a such a way or procedure to reduce the hazardous or eliminate the hazardous substances. So this is the basic fundas of the green chemistry. Understood? Now the question is that how the green chemistry differ from the cleaning up the pollutions. So this is the very, very important. Yeah, before I'm going to start the 12 principle of the green chemistry, this is more important, that why green chemistry is so much necessary in our life. That green chemistry reduces the pollution at the source by the minimizing or eliminating a hazardous of the chemical feedstock, reagent, solvents, and the products. Mind well, what happens in the normal conventional processes? What happens? We are using the basic solvents and all the other organic solvents or inorganic solvents, the reagent, feedstock are basically obtained from the non-renewable energy sources, and they are the most of the organic compounds or solvents are highly carcinogenic compounds. They are somehow more or less they are damaging the environment and causing the pollutions. So by the use of the green chemistry, we can minimize that particular we can work on that particular area, and we can minimize that particular pollutions level by using the green chemistry techniques, by using the green chemistry synthesis. Unlike, so we are here in this particular today's topic, we are going to discuss the microwave assisted organic synthesis, how it can help to reduce the pollutions and how it can help in the future to eliminate the hazardous chemicals and to protect our environment. Understood, please? So now we are going to discuss a 12 principle of the green chemistry. What are the 12 principles of the green chemistry? The first one is the prevention. It is better to prevent the waste from the formation to treat it after it is formed. So this is very important, that first of all, in the whatever the synthesis, whatever the organic compound which we are going to use, or any other solvents or anything else. But if we can remove it before it is being used, if we can replace it like any other green solvent, like in a normal organic reaction we are using methanol, ethanol and all that. By that, apart from that, if we can carry out the aqueous phase reactions, so we can reduce the pollution caused by that particular organic solvents. Understood? Next one is the atom economy. What is the atom economy? Design the synthetic method to maximize the incorporations of all the material used in the final product. Next one is the less hazardous. This is most important thing. The synthetic matter should be where the participant use or generate the material of the low human toxicity and the environmental impact. By the use of the green chemistry like micro-associated organic synthesis, chemistry, and other aqueous phase reactions, by this particular different types of processes, different types of methods, green chemistry synthesis, we can, what happens, we can regulate or we can reduces the toxic element which can eliminate at the end of the reactions. So it will help to what? To reduce the toxicity levels to protect our environment. The next one is the safer chemicals. The chemical product design should preserve efficiency while reducing toxicity. Next one is the safer solvents. Avoid the auxiliary materials like solvent extraction if possible, or otherwise make them incautious. Energy efficiency. Energy required should be minimized. Conduct synthesis at the ambient temperature and pressure. Renewable feedstock. This is very important, that whatever the material that we are using right nowadays, what to synthesize and in a particular dry dyes or drug industries, particularly the basic raw materials which we are using are obtained from the non-renewable energy sources like petroleum products. Whatever the, you can see the dyes right now we are manufacturing, whatever the new drug that we are manufacturing, basically are the monomers which we are using to synthesize that particular dyes or drugs are basically obtained from the petroleum products. They are all are hydrocarbons. But if we can replace that particular materials, likewise, if we can synthesize materials like if we can say polylactic acid, the polylactic acid itself a polymer which is made from the corn, which is made from the corn, and which is, first of all, corns are extracted, starch are extracted from the corn, and that starch is further converted into glucose and then lactic acid, and this lactic acid on polymerization gives polylactic acid, that we can replace it by any other polymer or plastic material that we can use it. Understood? So if we can use the renewable feedstocks, which we can continuously available, which we can generate it. Okay, so this is the basic idea of the renewable green chemistry, in which we can use the renewable stocks and remove or lesser the environmental toxicity. Understood? Please reduce the derivatives, that the unnecessary derivatization should be avoided wherever it is possible. Smart catalysis. This is very important. Nowadays, whatever the reactions we are carried out, we are using somehow the catalyst. Whatever the catalyst which we are using is also one type of organic material. So if we can choose any other catalyst like ionic liquids, which is a basically a basic idea of the green chemistry. Ionic liquid also a part of the green chemistry, in which we can use as a catalyst in the different organic reactions. Understood, please? In upcoming slide, we will discuss it. Smart catalysis, selective catalysis process are supervised to the stereochromatic processes. Degradable design. Chemical products should be designed to be generated in unconscious products when the disposal of not environmentally persistent. Real-time analysis for the pollution prevention. Monitor process in the real time to avoid the exclusion leading to the formation of the hazardous materials. Just a moment. Huh. Next one, hazardous and accident prevention. The material used in the chemical processes should choose to be minimize the hazardous and risk for the chemical reaction, such as releases, explosions, and fires. So this is very important that the basic idea of the 12 principle of the green chemistry is to reduce or eliminate the hazardous substances and generation of less toxic elements during the chemical reaction. This is more important. So basically, green chemistry is nothing but the green chemistry is approach in the chemical science that efficiently use a renewable raw material and eliminating waste and avoiding the use of the toxic and hazardous reagent and the solvents in the manufacturing and applications of the chemical products. The green chemistry takes into the account to environmental impacts and seek to the prevent or lessen that impact through the several key of principles that we had discussed. Okay, so just a moment, I'm going to change the slide. Okay, now so we are having the our main topic that green chemistry and our microwave included organic reactions. So first of all, we have to understand what is the microwave assisted organic synthesis. All of you are familiar with that. What's the microwave? First of all, we have to understand what is the microwave. That the microwave is a form of the electromagnetic energy. Mind you, what is a microwave? Microwave is nothing but the form of electromagnetic energy that falls at the lower frequency of the electromagnetic spectrum, and is defined in the 300 to 3 lakhs megahertz frequency range. Within that particular range of electromagnetic energy, only the molecular rotation is affected, not the molecular structures. Mind well. So what happens during the microwave synthesis? What is the basic idea about the microwave assisted organic synthesis? That is the preparation of the desired organic compound from the available straight material via some procedures. It may be single step procedure, it may be multi-step procedures involving microwave irradiations. Normally, whatever the reactions that we are carried out in the laboratory, in the chemistry, in the organic synthesis, are by using the conventional methods in which we are using the conventional heating. But here, in the by use of the microwave associated organic reactions, we are carried out the same kind of reactions in the microwave. So, what is the biggest advantage of this particular reactions? What is the benefit of the microwave organic synthesis? The very first one, it's a rapid reactions rate, clear reaction condition. This is very important. Enhancements of the chemical yields. So these are the three basic idea about the microwave assisted organic synthesis. Moreover that, what are the benefits of this particular microwave assisted organic reactions? We are getting the higher temperature at the minimum time. Next one is the faster reactions, and faster reaction in it means that means from the yield or from the reactant to yield, the time of the reaction, whatever in the conventional method, if we are taking 5 to 6 hours, by using the microwave reactions, we can reduce that. Understood, please? A selective heating or activations of the catalyst. Another one, we can have a absolute control over the reactions parameters. Mind one, easy access to the higher pressure performance. Next one, rapid synthesis in the lesser evaporation of solvent. This is very important. That by the microwave reaction, we can have a lesser evaporations of our solvents. Understood? So these are the benefits of the microwave assisted organic reactions. Now, here, just I'm going to change the slide. Okay. So here in the figure, you can see that. So what is the microwave reaction? Here you can see that what happens in the microwave reaction. Here you can see that we are using a conventional method. In conventional method, all the energies are uh, given to the vessel from all the directions, and the conventional currents. Here you can see that this part of the reactions are not get it heat directly, but when you are going to do the microwave reactions, what happens, you will get a direct heating to the solvent. The solvent get directly heated. So what happens in the next slide we will discuss, just a moment. So here the one video is shown, it is available in the internet also. So when you put any component in the microwave within a 1 or 2 minute, what happens? The reaction or the component will show in a normal stage. But when you add a reactant in it, it will get highly uh, reacted. Means what? That component, whatever the component which we are added as a reactant, the microwave radiation pass through it, and that particular molecules are get heated. Now in the conventional method, what happens when the vessel get heated first, while in the microwave only the solutions are get heated. In the conventional method, what happened? Both the gases and the solutions get heated, but too high pressure can cause explosions also. While in the microwave, we are only having the solution which are getting heated. Understood, please? We will see in the next slide what I will show the microwave which we are also using in the reactions to carry out different organic reactions. But you can see that different types of organic solvents which we can also use as a microwave solvents. Here see the range of the X-ray visible IR microwave and the radio waves. Now absorptions of the microwave energy occurs with by two mechanisms. The very first one is the dipole rotations, and second one is the ionic conductions. So these are the two basic things, two basic what I can say mechanism in which we can explain the microwave synthesis. First is the dipole rotation, and another one is the ionic conductions. So this is the dipole rotations. So here in which dipole rotation plays a very
Hello, sir.
important role.
Hello.
Hello.
Hello, sir. Sorry for disturbing. Sir, please open your camera.
Okay. Okay. Sorry, it stopped. So okay, I'm opening it. So I thought some light may cause interference, so I have closed my camera. Is it okay? The light is on behind me. So
Yes, sir. It's okay. Thank you.
okay, no problem with that, na? Okay. Okay, okay, no problem. So first of all, we have to understand what is the dipole rotations and what is the mechanism. Now, the condition appropriate for the microwave synthesis, the first one what we have to understand that by use of the solvent, the different solvent interacting very differently in the with the microwave because they are having their diverse polar and the ionic properties. Mind well, this is very important. Whatever the solvent that you are going to use in the microwave reactions, what happens that the different solvents interact very differently in the microwave. Almost all the solvents will react differently in the microwave because all are having the diverse polar and the ionic properties. Another parameter is the volume that the don't exceed fall below the vital specific volumes. Too low volumes gives the incorrect temperature measurement while the high volume does not leave the sufficient head space for the pressure which is going to be built up. Another one is the concentrations. While The concentration depend on the type of the chemistry that is performed, like higher concentration will gives a faster reactions. This is very, very important. All the different phases which can be used, like solution phases or solid phases or solid support reagents. This is very important. All the chemists which are working on that are very familiar with that, or any other reactions like solvent-free reactions can be also carried out into the microwave irradiations. The strings that all always magnetic string bars to the microwave reactions. Now, the benefit of the microwave reactions that the inert atmosphere is initially employed if needed to flow the vital inert gases before trapping. This is very important. Then what happens? Just a moment. Sorry. Okay. So inert atmosphere just can create it for the microwave synthesis. The time, the time durations is very, very important. Normally, in the conventional methods, whatever the synthesis that we are carried out, if it takes 8 to 10 hours in the normal conventional method, in the microwave irradiation, it will take hardly 2 to 15 minutes in the microwave irradiations. Understood? Another benefit of the microwave irradiations, MAOS, that it can maintain the temperature to 62 to 50 degrees Celsius. It can also nowadays some modern microwaves are available in which we can also maintain the pressure up to 20 bars. Another one, what is the benefit for this particular microwave assisted organic reactions? That the time prediction. The reaction proceed faster using the microwave synthesis simply because they are conducted at the higher temperature, like based on the Arrhenius equations that the 10 degree increases the reaction temperature doubles the reaction speed is. So basically it's not on it's basically it is on the Arrhenius equations. So we can also predict the time required for the particular reactions. Now, what is the optimizations? What is the optimization for the microwave reactions? That the optimizing the microwave synthesis is similar to the optimizing conventional synthesis. Like if the reaction fails, charging the target temperature. This is important. And the reaction time caused the significant improvement. So this is the benefit also for the microwave assisted organic synthesis. Now, I'm just going to change the slide. So this is the ionic conductance, as we have discussed, is also very important for the microwave assisted organic reactions. Now, why the microwave assisted reactions are necessary? Why we have to carry out microwave assisted organic reaction? The short reaction time, easy workup procedure, reaction may be carried out in presence of solvent. Solvent-free technique is facilitated easy of the synthesis of the library of the compounds. The availability of the commercial microwave equipment intent for the organic chemistry. So first of all, you have to understand the basic microwave associated organic reactions are work on the green chemistry and the green chemistry 12 principle. So you have to understand what is the green chemistry. The green chemistry, which is 12 principle, would like to see the change in the conventional chemical synthesis and the use of the less toxic starting materials. So this is the benefit of the green chemistry, that the green chemistry would like to increase the sufficient or efficiency of the synthetic method to use the less toxic solvent and reduces and stage that the synthetic route and minimize the waste as far as the particularly possible. So by the use of the microwave assisted organic synthesis, we can reduce the amount of the waste which is generated at the end of the organic reactions. So in this way, we can chemically synthesis will be the part of the effort for the certain sustainable development. The microwave assisted synthesis has the revolutionary chemical synthesis. This is very important. That organic synthesis which we are carried out in the laboratory in the normal conditions, but whatever the organic synthesis which we are doing it in laboratory can be carried out similarly, same kind of reactions that can also carried out by using the microwave irradiations. So this is the new effort for the sustainable development. The microwave-assisted synthesis has a revolutionary chemical synthesis. Small molecule can be built in the fractions of the time required for the conventional methods. As we have discussed in the upcoming slide also, we are going to discuss with some examples how the microwave reaction can reduce the time, how microwave reactions can reduce the eliminations of the hazardous substances in the chemical reactions. As I discussed that the small molecules can also build the fractions of the time required for the conventional methods. In the conventional methods, what happens? In the conventional heating methods, oil bath or water plate which we are using, oil bath, water bath or sand bath or whatever the heating we are using or direct heating which we are using in the chemical reactions. But in the microwave reactions which we are widely used source for the heating in the chemical reaction. So what happens? The basic mechanism which observes in the micro-assisted organic reactions is we have discussed the dipolarizations and the conductions. The micro-assisted synthesis provides the clean synthesis with the advantage of enhancing reaction rates. This is more important. By the use of the microwave, we can enhance the reaction rate. The reaction will complete it within a lesser time than the conventional methods, and as well as we are getting the higher amount of yield. As we compare with the conventional process, the conventional methods takes so much long time compared to microwave reactions, and as well as the amount of the yield is lesser compared to microwave synthesis. Understood? So by the use of the microwave synthesis, we can two things. Biggest advantage of the microwave reactions. First, we can reduce the time required for the chemical reactions. So in chemical terms, you can say that we can enhance the reactions rate. Another one, we can remove the or lesser generation of the hazardous substances. What happens? Whatever the organic solvents that we are using in the chemical reaction, that we can replace it by any other green solvents, and by the use of the organic microwave irradiations, we are having a higher amount of yield. So compared to conventional method, we are getting the higher amount of yield. So that's why if you compare microwave heating and the conventional heating is more powerful than that of microwave heating. Understood? So the microwave assisted synthesis is the rapidly become a method to choice in the modern chemical synthesis in the as well as in the drug discovery. The present presentations in my presentation today is discussed about the microwave synthesis in the organic reactions, inorganic reactions like other than nanoparticles and pesticides and all the other things. Understood? Please. So I'm going to change the slide. Just a moment. Hmm. Now, what are the demand for the microwave assisted organic reactions? That the short reaction times and expanded the reaction range that offered by the microwave-associated organic reactions synthesis are suited to increase the demand in the industries. So all of you are very familiar with that. The industries in R&D centers, in pharmaceutical industries, in dyes industries, they are now in a race to produce the new drugs or new dyes. So at that time, the manpower as well as the time periods for the synthesis of new drug or a new dyes is so much important. So at that time, such type of processes, such type of innovation, such type of chemistry is very, very important. In the particular, there are requirements in the pharmaceutical industry for the high number of the newer novel chemicals entities to be produced, which are required chemists to employ a number of resources to reduce them for the synthesis of the compounds. The development in the synthetic chemistry have generally been concerned with the novel and the highly reactive reagents in the solution or a solid supports. Just a moment. Hmm. Now, how microwave reaction does. The organic reaction required to supply of the heat energy. This is generally achieved by the using of the traditional heat transfer equipment such as oil baths, sand baths, and the other heating jackets, as we have discussed. That by using such type of energy sources, we can carry out the conventional organic heating. These are the generally slow and consume of large excess of the energy than required. This is more important. What happens by using this such type of conventional processes? We are hitting out the reaction, but so much amount of the energy are also going to be wasted in the environment. It's not consumed by those particular solvents. It's not consumed by this particular reactions which are carried out in this RBF or any that vessel which we are carried out for the reactions. Now, in addition, the local overheat may occur cause of the decomposition to reagent or a product. This is also maybe happened. We don't know uh, if we not specific about or if we are not take care about the heating of the reactions. At the end of the reaction, whatever the product which we are getting, it might get decomposed. But in the microwave reaction, we can regulate the temperature as well as the pressure. So by maintaining the temperature and pressure, we can regulate the reaction rate as well as the temperature and pressure of that particular reactions. Understood? The microwave radiations is triggered only the heat and the sample depending on its dielectric behavior. The last one is not shown. It's easy to control the energy supplied to the sample, and whatever the energy which we are passed to the sample for the reaction, that we can control it by the processes, by the equipment. Understood? Just a moment. I'm just going to change the slide. Okay. Now, the mechanism, how it works. The microradiation passes through the walls of the vessels, heat the reactants and the solvent, not the reaction vessel itself. If the apparatus is properly designed for the conventional, just a moment. Okay, I think this question answers which are coming is for the participant. Okay. Hmm. If the apparatus is properly designed for the conventional and the temperature increase will be informed throughout the sample, which can leads to the less by the product or the reactants. So what happens in the microwave irradiations? We can design apparatus. In the previous slide, I have shown that. You just see this slide. I'm just going to show the slide here. In the this particular chemical reactions, what happens? By the conventional heating, the vessel are heated from the all the directions, but the inner molecules of this conventional heating are not heated completely. But in the microwave radiations, what happens? The absorb the microwave energy. Solvents molecules which are present in the vessels are absorb the microwave energy and it is that micro energy are converted into heating. Whatever the energy which we are absorbed by the solvent molecules are converted into heat in the form of heat, and which are used to activate the reactions. Mind well, just a moment, I'm having some technical issues. Okay, okay. So in this topic, I have shown how the microwave heating works. Now, how the reactions are carried out in the microwave reactions. The reactions are carried out generally in two types of reactors: the commercially available microwave synthesizer and the domestic microwave oven. In generally, all the reactions are carried out in the vessel made of glasses. Just a moment. Now, what are the advantages and disadvantages for the microwave synthesizer? Whatever the microwave reactions which are carried out, whatever the organic reactions which are carried out uh, are important. Just a moment, just hold on. What are the advantages and disadvantages for these reactions? That advantages are control for the reactions. Maintenance the temperature can be combined with the pressure techniques. Just a moment, I am having some visitor. Okay, what are the advantages for the microwave synthesizer? That the control of the reactions, maintain the temperature, can be combined with the pressure techniques. What are the disadvantages? That if you are going to compare with the conventional method, it's expensive. Some features are redundant. Now, what are the domestic microwave oven? Advantages for the domestic microwave oven, that the most features are available. The recent oven have some control through not the extent of the synthesizer is expensive. What are the disadvantages? That the lack of the complete control may lead to the runaway reaction decompositions. Not equipped for the reaction that occurs in the sealed tube or other vapor pressurized component. Understood? So these are the advantages and the disadvantages of the domestic microwave ovens. If you are going to compare the with the conventional microwave oven and the domestic microwave oven, so these are the advantages and the disadvantages of the uh, reactions or microwaves. Now, here, the comparison between the domestic versus the modified microwave oven. The advantages, more features are available. That means you can control the temperature and pressure both at a time for the chemical reactions. The recent ovens have some controlled devices. It's expensive also. What are the disadvantages for this? Lack of the complete control may lead the runaway reactions and decompositions. The reaction that occurs in the sealed tube and other pressure conditions are not possible at all. So these are the advantages and the disadvantages for the reactions, microwave ovens. Now, the experimental methods. The most reaction reported in the this particular literatures and carried out in the microwave oven, one of the following methods. The first one is the reaction carried out open vessel using the solvent's high dielectric constant, reaction carried out at the sealed tube, reaction in the dry solventless conditions. So these are the three different experimental methods. Now, the question is that which type of reaction can carried out in this particular microwave oven? The reactions that are conventionally run by the thermal processes. This is important. But nowadays, there are some advanced microwaves are also available, in which the in which we can, if we can maintain the temperature less than 0 degree, we can also carry out such reactions. The reactions like protection, deprotection, condensation, oxidation, reduction, rearrangement reaction, Diels-Alder reaction have been extensively studied using the microwave ovens. The recent developments are decided to use the microwave radiations in the dry conditions. Now, these are the some images of our microwaves which we are using in our laboratory. It's a modified microwave ovens in which we can maintain also control the temperature and pressure both at the same time. So one of the type of the Q Pro modified microwave oven which we are using in our laboratory. So these are the two different pictures that I have shown to you, in which we are using such type of equipments for the microwave assisted organic synthesis. So here, these are the inner part of the microwave synthesis. So these are the condenser which we are attaching with the RBF, and this rod which we are used to pass the microwave irradiations. By the passing this microwave irradiation, the solvent get heated. Now, some examples for the microwave associated organic synthesis, how we can carry out such reactions. The very first one is the oxidation reactions, that the methyl group and the other side chains in the aromatic compounds are oxidized by the chromate and permanganate to give the corresponding carboxylic group. Side chain oxidation is an important method to preparing the organic carboxylic acid and also aids the identifications of the aromatic hydrocarbons and their derivatives. Since the acids are crystalline solid that can be purified and characterized easily, the oxidations of toluene to benzoic acids, paranitrotoluene to paranitrobenzoic acid, orthochlorotoluene to orthochlorobenzoic acids, anthracene to anthraquinone, benzoin to benzyl, paraxylene to terephthalic acid was carried out by more techniques, and results have been compared with the conventional processes. So here one example is shown here. I'm just going to show you the reactions. Okay. So here in the slide, you can see that the both the reactions, this reaction you may carry it out via conventional method also. Same kind of reaction you can carry it out via microwave also. So here in this reaction, you can see that this particular reaction in which the toluene is converted into benzoic acid, in the microwave irradiation, it will take hardly 7 minutes for the reactions. Mind well, it takes hardly 7 minutes. Or actually, if you will see the reaction, if you carried out the reaction, it will hardly take a 5 minutes to complete the reactions. And if you compare the yield for the particular reactions, so here in this particular literature, you can see that the same reaction was carried out by the conventional method as well as the microwave. And comparison status, here it is shown that here you can see that there is only 5 minutes are required to complete the reactions, while in the conventional methods, what happens, it will take half an hour. Understood, please? Now, if you compare the yield percentage in the conventional method, you can see that there is a amount of the yield is near about 34.8% only, while in the microwave you will get 45.5%. So this is the biggest advantage for the industries because they are now in a deal with the different novel compounds. So at that time, the amount of the yield is very much important. So for the next new future development, for the new synthesis of the new products. Understood? So this is the method which we are using for the synthesis. A mixture of the toluene and Na2Cr2O7 in the 50 ml of the water and zero point 0.2 normal potassium hydroxide NaOH was taken in 150 ml of the Alzheimer fall flask, fitted with the funnel as a loose toe, and this was irritated with the microwave oven for the 5 minutes. After cooling, the reaction mixture was extracted with the ether and removed the unreacted toluene. The aqueous layer, this unreacted toluene that you can remove it via any extraction method, via any, or you can distill it off. The distillation process is very simple. The aqueous layer was acidified with the H2SO4 solutions, and then it was extracted with the ethers. This extract was dried and crystalline compound was isolated by the evaporations of ether. So this is the one of the simplest method to understand what is the importance of the microwave irradiations. Understood, please? Yeah, another one, another example here it is shown the oxidations of the anthracene. So here in the oxidation of the anthracene, you can see that the reaction time required for the microwave reactions is hardly 8 minutes, while in the conventional method, the time required to complete the reactions means to carry out the reaction to produce the anthracene from anthracene is near about 1 hour. Understood? So here in the literature, it is shown that the same reaction was carried out by the conventional as well as the microwave method, and the comprehensively status is given below. So, so the reaction here you can see that the rate of the reaction time for the microwave is near about 8 minutes, while in the conventional method it is near about 60 minutes. Now the percentage of the yield via microwave methods is near about 68.5% only, while in the conventional method it is near about 61.7. So if you compare both these things, so microwave reaction is more advantageous than the conventional method because we will get the higher amount of yield, higher percentage of yield with the minimum time required for the chemical reactions. Understood? So here in this process, the process is shown here that the 3 gram of Cr2O3 was dissolved in the 10 ml of the water, and then 15 ml of the acetic acid was added to the solutions. The solutions of the anthracenes is near about 2.5 grams. In the acetic acid, 30 ml of acetic acid was added. The reaction mixture was kept in the room at microwave oven for the near about 8 minutes. The reaction mixture was cooled and poured into the cold water with the stirring. The solid product was filtered, washed, and with the water and recrystalline from the alcohol. Understood, please? So here, in the next slide, I'm going to show some comparison of the microwave and the conventional method. So here in this slide, you can see that there is a completion comparison of the oxidation reactions. First one is the substrate, means the reactant which we are using, and the product which you are getting at the end of the reactions. And in the another one, just two row columns are shown the conventional and the microwave method, the comparison between the conventional and microwave method. In the first one, in the from the toluene to benzoic acid, you can see that in the reaction time required for the conventional method is near about 30 minutes, while in the microwave there is only 5 minutes required. If you compare the yield percentage, in conventional method, you will get 34.8% yield, while in the microwave method, you will get 45.5%. And the another example is para-nitrotoluene to para-nitrobenzoic acid. The time required in the conventional method is near about 30 minutes, and in microwave, you will get hardly 7 minutes. In orthochlorotoluene to orthochlorobenzoic acid, conventional method required near about 180 minutes. This is more important. Means near about 3 hours. So while in the microwave, you can complete or carry out the same kind of reactions with the higher percentage of yield, near about 70% of the yield we will get at the end of the reaction, but within a 10 minutes. Understood? Same examples are given: anthracene to anthraquinone, benzoin to benzyl, paraxylene to terephthalic acids. So these are the examples, some examples of the oxidation reaction which you can carry out in the microwave reactors, in which we will complete the reaction in the minimum time with the higher percentage of the yield. Understood? So please, it is a clear form that the data is stable, that yield of the product is the various oxidation reaction increases to the reasonable extents only, but the reaction time was reduced appreciably. They clearly reflect that the utility of the microwave method over the conventional methods. Understood, please? Just a minute, I'm going to change the slide. Now we are going to discuss the new method, esterifications. We had discussed the oxidation reaction. Now we'll have esterifications. That the esterification reactions of the benzoic acid with the methanol, ethanol, propanol, butanol, esterifications of the salicylic acids and the cinnamic acid with the methanol were carried out by more techniques, and the result are compared with the conventional procedures. It was observed that the microwave dramatically reduced the reaction times and significantly increased the yield of the products. Just a moment. So here in this slide, you can see the reactions, the esterification reactions of the benzoic acid with the methanol. So here you can see that the reaction is carried out in the presence of methanol. The H2SO4 is being used, and this reactions is irradiated in the microwave oven for only 5 minutes. So the same reaction was carried out by the conventional method as well as the microwave method, and the comparison here is shown that the time required for the microwave irradiations in this particular reactions is near about 5 minutes, while in the conventional methods, the same kind of reaction takes 360 minutes. So near about 4 to 5 hours. So it's a long time. So while using the conventional method, if we can carry out the same kind of reactions within a 5 minutes, so it's a good task. So if you can compare the percentage of the yield, percentage of the product, see the difference. If by a microwave method, you will get 72.7% of the yield, while in conventional method, you will get 64.8% of the yield. Here in the process, the 2 gram of the benzoic acid was taken in the Alzheimer flask, and 2.0 ml of methanol was added to it. It followed by the additions of 1.0 ml of concentrated H2SO4. The reaction mixture was subjected to the microwave irradiation at the 40% level in the microwave oven for only 5 minutes. This is very important. The contained were transferred into aqueous sodium bicarbonate solution, and product was extracted in the ether, and ethereal level was dried. Now another one, in the next slide, I will show the esterifications of the benzoic acid with the ethanol. So here in this particular reactions, you can see that the reactions of the benzoic acid is carried out in presence of ethanols. This particular reaction is irradiated in the microwave oven for the 5 minutes. So here the comparison is shown below. In microwave, this reaction is carried out near about 5 minutes, while in the conventional method, the same kind of reaction will take near about 240 minutes. Understood? So, and if you compare the percentage of the yield, there is a clear difference is that via the microwave reactions, you will get 69.4% of the yield, while in the conventional method, you will get only near about 62% of the yield. Now I'm going to show the some table which I have shown in the oxidation method also. At that time you will see the comparison for the esterification reactions. So here in this esterification reaction, you can see the comparison that benzoic acid and methanol, benzoic acid and ethanol, benzoic acid and propanol, benzoic acid and N-butanol, salicylic acid and methanol, cinnamic acid and methanol. So here you can see the comparison between the microwave and the conventional methods. So in the first one, in the benzoic acid and methanol, the time required for the reaction in the conventional method is near about 360 minutes, while the same kind of reaction is carried out in the 5 minutes in the microwave. Understood? So to see the third example, the benzoic acid and propanol. See the comparison that in conventional method, this process is near require 450 minutes, and in my same reaction is carried out within a 20 minutes in the microwave. And compare the percentage of the yield at the end of the reaction, that the percentage which we are getting at the end of the reaction via microwave method is near about 75%, and in the conventional we are getting near about 68%. So from this table, it is clear that the clear from the data is in the table, that is the yield of the product is various esterification reactions increases to a reasonable extent only, but the reaction time was reduced appreciably. This clearly reflects that the utility of the microwave method over the conventional methods. Understood, please? Just a moment, I am going to change the slide. So in the next slide, I'm going to show the same kind of percentage and the time required for the conventional and the microwave. Same, just comparison is shown here, nothing else. So here in this form, clearly from that data is stable that the yield of the product was various esterification reaction increases to the reasonable extent only, but the reaction time was reduced appreciably. This clearly reflects the many utility of the microwave method over the conventional methods. Now the another one reaction that we are going to discuss is the benzoylations. What is the benzoylation reaction? That the substitutions of the hydrogen atom of the hydroxyl group and amino group by the benzoyl group is known as the benzoylations. This reaction can be carried out via conventional method also, but same kind of reaction that you can also carry it out via microwave method. It is not possible to carry out the benzoylation reaction using benzoic acid, but in the presence of microwave, benzoic acid can be used for the benzoylations. In the present work, it is proposed to use the benzoic acid for the benzoylations of the formic acid and substituted phenols. Now I'm going to show the reactions of the benzoylation. So here you can see that the reactions of the formic acid and benzoic acid is carried out, and the microwave reactions is the formation of benzoyl formic acid. The formic acid and benzoic acid were taken in the enzymal flask fitted with the funnels at the loose top, and it was subjected to the microwave radiations at the 40% power in the microwave oven for the 1.0 minutes. After the completion of the reaction, as mentioned, monitored by the TLC, the contained were poured into the crushed ice, and it was stirred with the 15 minutes and filtered. The solid product was transferred into the aqueous sodium bicarbonate solutions to remove unreacted benzoic acid. The solution was filtered, and solid residue was washed with the water. The product was recrystalline with the acetones and characterized by this IANMN and other elemental analysis. So I'm going to show some other examples for the some kind of benzylation reactions. So here are some examples of the benzylation reactions are shown here. Here you can, in this particular reaction, you can see that the reaction times of the particular reaction in the microwave irradiations is near about 5 to 7 minutes. All these reactions from alpha naphthol and benzoic acid both are reacted together under the microwave irradiations. The reaction require hardly 7 minutes. So in the same way, phenol and benzoic acids are also react with each other in the under the microwave radiations require hardly 5 minutes. In the similar way, beta naphthol and benzoic acid are reacted with each other in the microwave radiations. The time required for the completion of the reaction is near about 8 minutes. Understood? So here, if we can compare these things in the table, see from this table, if we compare these things, so the time required and the percentage of amount which we are getting at the end of the reactions, so we can see that it's a clear form of observation that one can successfully carry out the benzylation reaction using the benzoic acid in the microwave oven. The yield is good, even the reaction times are quite short. This clearly shows that the microwave method is a suitable method for the benzylation reaction. So here we have several examples are given. So microwave reactions are not restricted only for the one type of reactions. The numerous kind of oxidation reactions like benzylation reactions of other examples that also we are going to study. So different types of reactions may be carried out under the same kind of conditions. I'm going to show another table. So here in this table, it's shown that the microwave include acetylations. So acetylation using the glacial acetic acid in the solvent-free conditions. So here the numerous substrate and the product means reactant and the products are shown here, and the comparison of the timing required for the reactions is also shown here. The minimum time required in the microwave radiations and the percentage of the yield. While in the conventional method, if you compare the such things in the conventional method, you can see that the amount or percentage of the yield is near about 50% or 60%, more not more than that. While in the microwave, you will always get uh, percentage of the yield more than 65%. In some cases, it's near about 80 to 90%. So it is more advantageous to carry out such reactions in the microwave compared to conventional methods. Okay, so another one is here shown here. Examples: the microwave induced acylation reaction using the glacial acetic acid is the solvent-free conditions. So here it's comparison will also show the formic acid resulted into benzoyl formic acid. The time required for the under the microwave irradiation is only 1 minute, and the percentage of the yield is near about 76%. In the similar manner, phenol is converted into phenyl benzoate. The react time required for the completion of the reaction is near about only 5 minutes, and the percentage of the yield is near about 83%. And this kind of things is not possible in the conventional method. It is only possible when you carried out such reactions in the microwave. Understood, please? Some other examples are also given here. You can see in this table. Now, in the next slide, I'm going to show you oxidation that we have already discussed. That not we are going to discuss it again. The esterification reactions. What is the esterification reaction? Here in this esterification reactions, the same reactions is carried out at the conventional and the microwave, both the methods. Here you can see the time comparison. In this reaction, 2 grams of benzoic acid were taken in the Alzheimer's flask. 2.0 ml of methanol was added into it and followed by the addition of 1 ml of concentrated H2SO4. The reaction was stirred subject to the microwave radiation at the 40% level in the microwave oven for the 5 minutes. So this contained was transferred into aqueous sodium bicarbonate solution, and the product is near about uh, near about 72.7 percentage. Understood, please? Just a moment, I'm just going to change the slide. This is the table as we have discussed earlier, so I'm not going to discuss it. Benzylation also we have discussed. Some other with the other example is shown here. Now, striking the rate enhancement. What is the striking the rate enhancement? What happens? So I can here you can is this particular reaction. You can see the comparison between the microwave irradiation and the conventional procedures. So in the conventional procedures for this particular reactions, the temperature requires near about 100 degrees Celsius, and this 72 hours. This is very very important. This particular reactions takes 72 hours to complete the reactions. So if we are having the such kind of reaction which is required so much timing to complete, if we can carry out such reactions in a microwave, it will complete within a 10 minutes. See here, the comparison is show we are using the DMF as a solvent, and the reaction is carried out at 200 degrees Celsius in the microwave. So at the time required for the completion of the reaction is near about only 10 minutes. Understood, please? So this is the power for the microwave assisted organic synthesis. Another example I'm going to show you. Just a moment. Okay. So here for this comparison, if you can see the reactions, these particular reactions are required 42 hours in the conventional method. Mind well. Basically, it's aqueous phase reactions. It's also green chemistry, but it required 48 hours to complete the reactions, while in microwave it hardly take a 30 minutes. Mind well. So this is very very new development. Another examples for the rapid method development. This in this particular reactions, if you carried out such a reactions via conventional methods, it takes 48 hours, and the solvent which you can use in this reactions is toluene, and at the end of the reaction you will get only 20 to 25% of the product. Mind well. But in the micro methods, the same reaction is carried out in the 10 minutes to 30 minutes, and the percentage of the amount of the yield is higher than that of the conventional methods. Understood, please? Next one, for this particular reaction, the reference is given here. In the conventional methods, the overnight reflux is required to complete the reactions, while in the microwave the same kind of reaction is carried out within a 5 minutes. Understood, please? Some other examples are given here. In this particular reactions, what happens via conventional methods is required near about 48 hours. Mind well. And the concentration of the NaOH is also higher. While in the microwave reactions, what happens? The same kind of reaction is carried out within a 8 minutes. Okay, it's a reaction required so much less time to complete. Understood? So that's why the microwave reactions are preferred. Another one more examples are given here. That just a moment. Hmm. In the conventional methods, 52% yield after heating on the at the end of the reactions, methoxyethanols. So while in microwave, this particular reactions is require only 5 minutes. Now, this is the multi-step reactions, but all the steps it can carried out via microwave method very easily within a one vital steps and one purifications. So multi-step reactions and one part sequence. So this is also biggest advantage of the microwave radiations and microwave assisted organic reactions. Now, one more examples are given here. Just a moment. It's a three-step reactions. It's also three-step reactions. Now, in this reaction, just a moment. I'm just sharing the slide. Change the slide. No, it's a complete one. It's a complete one. Huh. So it's a two-step reaction, multi-step reactions, in which both the reactions, the first reaction takes overnight time, another one it takes also 4 to 5 hours, but the same kind of reactions is carried out under the microwave radiation near about 10 minutes. The purification consists of the filtration of the reaction is near about 95% of the purity. Understood? Please. So just a moment. So these are the other examples are given of the reaction, microwave reactions. Now, the microwave assisted synthesis. Just a moment. Assisted synthesis for the furforaldehyde derivatives via aldol and the novel condensations. So these are the examples of the reported name reactions. So such kind of name reactions can be also carried out using the microwave reactions. And this is the reported process and published by the J. Babu in 1997. Another one is the cyclization reaction, which is shown in the next slide here. So such kind of cyclization reaction is also carried out using the microwave radiations, and at the end of the reaction you will get more than 80% of the yield. Understood, please? Just a moment, I'm just going to change the slide. These are the some also cyclization reaction which can also carried out using the microwave irradiations. Synthesis of the quinoline derivative. This is very important thing because the quinoline itself are used very much important compound for the in the synthesis of the some novel heterocyclic compounds, in the synthesis of some novel drug discoveries. So synthesis of the quinoline compound via microwave is so much having so much importance. So in this slide you can see that we can use the microwave irradiation to produce the quinoline derivative, and the time required is not shown here, but the time required for the completion of reactions is near about 10 minutes. So within a 10 minutes you can synthesize this quinoline derivative, substituted quinoline derivatives. Understood? And this is also a reported process which is shown below here. Here in this slide there is a table shown here, the different quinoline derivatives used via synthesized via microwave and by the conventional methods. The first example show that it requires 2 hours for in the conventional methods, while in the microwave it hardly requires 2 minutes. Some others derivatives shown in the tables. So in the microwave methods it hardly required 2 to 3 minutes to synthesize such compounds, while in conventional methods it's required near about 2 to 3 hours. Understood, please? Some examples for the oxidation reactions we can also carried out at the microwave. Synthesis of 4-alkyl pyridines. The substituted 4-alkyl pyridines are having the very good uh, antimicrobial effect, biological activities. These are the tables in comparison between the microwave and the conventional heating. Now, this is more important, synthesis using the Wilsmer reagents. So, as we have discussed, the microwave radiations are very much important, but we can also use some name reaction. We can also carry out the name reactions and also use the some knowing reagent in the microwave irradiations to complete the reactions also. Just a moment, I'm just going to change the slide. So same kind of reactions. So here you can see that the POCl3 can also used under the microwave irradiations, and the time required for this completion of the reactions is only 30 seconds, not more than that. Synthesis of 4-alkyl 1,3-dipyrazole, time required for the completion of the reaction is near about 30 to 50 seconds only. The same kind of reactions, some examples are given: 1 pyrazole, 4 carboxylic acid esters. The time required to complete the reaction is near about 3 minutes. The table is shown here, the percentage of the yield and the time required for the completion of the reactions. This is the mechanism that we are not going to discuss here because we are going to learn the microwave radiations. Some chloroquinoline were obtained by the cyclization of orthoazidochalcones under the microwave irradiation. So we can also synthesize chalcones in the microwave radiations. Here the examples are given here, in which we can see the comparison between the microwave and the conventional heating. Three components coupling. The multi-component coupling reactions can be also carried out in the microwave irradiations. And this is the reported process by S. Nandagopal, is shown below here in 2003. It's a binary reactions. This is important. This is the name, very well-known name reaction. This particular reaction can be also carried out under the microwave irradiations. Mind you. The synthesis of novel 3,4-dihydropyrimidinone on the water-soluble solid support catalyst indium triphthalate. So such a reaction is also carried out under the microwave irradiations. Some other examples are there in which we can use the microwave to complete the reactions. So here you can see that the time required for the completion of the reaction is near about 2 to 3 minutes only, and the percentage of the yield in the most of the cases is near about is more than 80%. Another examples of the deprotonation reactions. The deprotonation reaction can be also carried out using the microwave radiations. Some examples are given. The table is for the comparison. Understood, please? Cycloaddition reactions. This is also very important in the chemistry. The cycloaddition reactions can also carried out using the microwave radiations, and the reference are given below here. Understood, please? Thank you all for this opportunity. I would like to thanks the IGP to give me this platform and share with you my presentations. I hope in future also I will continuously be in touch with you and give the another topic and discuss on the same things. Thank you, sir.
Thank you so much, sir. And it was really amazing session. I was learning so many things, and along with us, also I can see the interaction the people are doing here. So, sir, we can start some Q&A. There are some questions people were asking from the beginning. So, Kamrul, sir, would you mind to highlight some question from the audience? All right. So,
Okay, so
um,
if they are not having any questions, then you should share my mail ID. They can ask me anytime on this my mail ID. No problem with that, sir.
okay, sir, we'll do that, but there are some questions people want to know actually. So,
Okay.
Kamran sir, would you mind to highlight some question from the comment box? There are some question from the YouTube as well. So, sir, it was really vast area, vast thing you are describing. I would like to know something very shortly in a like simple way. So, where
Hmm.
this green chemistry is using right now?
Sir, basically, green chemistry's idea come from that in which we can reduce the pollutions, in which we
Mhm.
can use chemistry in a such a manner to reduce the waste, or we can eliminate the hazardous substances. While in
Right.
conventional method, what happens? In conventional methods, we are using the conventional heating by oil bath, sand bath, and other things. While
Mhm.
in green chemistry, we are using the micro irradiation. The sonochemistry is also there, in which we are giving the direct energy or direct heating to the solvent. So, in the minimum time required to complete the reaction and the end of the reaction, we are having a lesser amount of the hazardous substances, and we are getting the higher amount of the yield.
All right, it's really vast. Sir, except chemistry student or the Department of Chemistry and Physics, is there any department or faculty where green chemistry is studying or involved already,
Hmm.
especially at the university level?
Sorry, I can't hear you properly, sir. Can you
Okay,
repeat it?
so yeah, my question is that except chemistry department or faculty, chemistry, physics, or biology, that
Okay.
those faculties, is there any department or faculties where green chemistry or microwave are studying right now?
No, basically it's belong to chemistry and physics peoples,
Mhm.
which are going to synthesize the new compounds, especially drugs and different types of dyes in industries. They are utilizing such a techniques to synthesize a novel compound within a lesser time.
All right. So, sir, if someone went to study the green chemistry or the microwave, so where like how would be the future, especially the job field? Do you think that
Y-
it has demanding job or
Yeah,
especially
yeah, yeah.
everyone has the same intention, it's the same question actually.
Yeah. It's a basically it's very important because right now in R&D works in industries, in laboratories, in which they are going to synthesize a new compounds. So industry are want to synthesize a new compounds or novel chemistry within a lesser time, and the amount of the yield for the future development with the synthesizing a new compound. Because what happens, whatever the synthesis compound which are going to synthesize in laboratory is not going to be full stop. That means it's not a final compound. There's so much research is going on the, or so much chemistry is also going on within that molecules. So we require the high amount of the yield as well as within a lesser time. So the microwave chemistry provides the both the things, that we can synthesize a compound within a lesser times with the higher amount of the yield. So that's why the microwave assisted organic synthesis are very much important.
All right. So, sir, especially in the South Asian, in Bangladesh, Pakistan, India, so is there, like the good way or platform where people can study? I know, as per my concern, India might have some opportunity. Some university has the department, and Bangladesh also have. But is there, as per your concern, is there any good platform or the institute where people can study the advanced chemistry or green chemistry?
Yeah, there are so many institutes are there. As far as I, if you concern the Bombay universities, Ukhatasar University, we also carried out such kind of green chemistry reaction. We are also working on the nanoparticles and all other things. There are so many universities in India, and they are working on this particular green chemistry. like sonochemistry, micro-assisted organic synthesis. We're also working on the aqueous phase reactions, different types of aqueous phase reactions.
All right. It's really good to know that. Sir, I would like to ask you one personal question.
Yeah.
When we hear that someone is a doctor, there's an assumption he would be like old age, like about say 55. I can see this, you are too young and energetic. So can you tell me like when and how you just acquired this, how was your journey actually, educational journey? I know this is a very personal question, but I'm
Oh,
really
no, no,
curious.
no, thank you very much. But I'm not that young. I'm 41 years of age, uh,
Mhm.
and I'm right now working as an assistant professor in Kolkata Study University. I had completed my PhD near about at the age of 31, I think. After the master, I immediately joined with the PhD in the Wiener Massachusetts University under the guidance of Dr. K.R. Desai, and I had completed my PhD under the same title, Green Chemistry. And right now also I'm doing the research on the same field, green chemistry, as well as also I'm doing the research on the micelles and the nanoparticles.
Wow. Still you are in a learning process. This is really good, I think good. Yeah, your generation, our generation, the next generation can be the, our generation can be the inspired from you guys. In our Asian culture, there is a culture who, your study should be stopped within 30 years or 35. After 30 years you have to be very busy with your family, like business. But this is really nice. Some of you guys are, still studying, still doing something good, innovating for the new generation, trying to bring something for the new generation, for the new world. This is really soothing, sir. Thank you so much, sir, for
Thank you.
joining, and it was really nice session. I really learned so many things. Though I'm an engineering student and chemistry was also at my department, university college, but it was something advanced, and I haven't
Thank you.
ever listened this type of, the content.
Thank you. Thank you.
Thank you so much,
Thank you.
sir.
Thank you. Thank you.
So thanks all, thanks to everyone for joining. So see you another session. If you want, you can you can share, this video. I think this is the session. This is the platform actually where if you just go to the YouTube, if you are searching green chemistry, I am pretty sure you will get some less content. But that was, this content was really deep and deep analysis. It can really help the so many students. So it's like that. There are so many interesting topics. If you want to share, if you want to learn deeply, I think this can be the best platform. Don't keep learning or sharing in yourself. Try to share with your friends, family members, and other, let to other people to learn. So I think this thing can really help you. Thank you so much for joining, guys. See you another session, and tomorrow we have also other session as well. Don't forget to share, don't forget to join with us. And this is completely free. You can also, if you wanted to get the certificate, you can use the code IGP7645. So 54, sorry. So without no code is, if you want to participate certificate, you can just you need to just go to the website and after place this code IGP 7644 uh, 54, sorry. So it through this placing this code you can acquire the certificate. This certificate definitely should have value because it is already recognized so many organization and already reached more than 100 certificate. I hope you could learn something. We are able to give you something new, and for me it was completely new subject. And because I studied though I studied chemistry at my college university, but that was really advanced level of chemistry. So for us like me, I think you guys can also learn something, and further we will continue learning and we will grow together. And don't forget to take your certificate. See you very soon.